Understanding polynomial expressions. Definitions. A monomial is an expression consisting of a number, variable, or product of numbers and variables that have whole number of exponents. So you can classify monomials as single term. So here we have one term. We have a product of numbers and variables, which is one term. Here we have a product of numbers and variables with an exponent. And here we have a product of x and y with 4. So examples of not monomials is if we have two terms, that's not a single term, two terms again. If we can rewrite the variable as in denominator of a fraction, so this is the same as 0.7 over x squared, so not a monomial. We can have numbers in the bottom because we can rewrite this as this, but we can't have exponents on the bottom. Same with this one right here. I can rewrite my exponent in the bottom, and then last we have exponents on top and the bottom. So these are examples of monomials, and here are examples of not monomials. Classifying polynomials. A polynomial is just a monomial or a sum of monomials, any number of terms that can be a polynomial. So you can have a set of terms like x squared can be a polynomial. X squared plus x can be a polynomial. X squared plus x plus 1 can be a polynomial, right? So polynomial classifies all types of sums of polynomials. A binomial goes more in depth of what it means to be a polynomial, and that is a sum of two monomials, which really, if we go back to our previous example, that would only apply to this. Because we have one term, two terms, and bi meaning two terms. A trinomial is a sum of three monomials, which we can take our example from previously as x squared plus x plus 1. Here we have one term, two terms, three terms. And the degree of a polynomial is the greatest value of among the sums of exponents on the variables in each term. So what this means is if I have something like this, then my greatest value among the sum of the exponents for each variable, in this case, would be this one, because this one's my highest exponent right here of 3. But let's say if we had something that looked like this, x. Now in this case, the greatest value among the sums of the exponents in the variables in each term would be here. Because I'm taking the 3 and the 4 and adding them together to give me 7. So the greatest value among the sums of the exponents to determine the degree of the polynomial in this case would be looking at these terms here. This would be a degree polynomial of 3 plus 4, which make it 7. Example 1. Classify each polynomial by its degree and number of terms. So as established in the previous slide, we're going to take a look at the exponents in order to classify this. So here we have a 2, and here we have a sum of 3 and 3. So if I take these two exponents and I add it together, then 3 plus 3 becomes 6. So I can classify this as a degree 6 polynomial. Okay. Now I have to look into see how many terms this polynomial has. 1 and 2. So I can determine, because it has 2 terms, this polynomial can be further explained to be a binomial. So it's a degree 6 binomial. I want you to try this problem. Pause the video here for about a few minutes, work through the solution. All right, if you're back, we're moving on. We're going to take a look at the highest degrees. So in this, we have a 4th degree that makes up these two. Now, if you don't see anything for a variable, then you can go ahead and add a 1. So that would make this a 3rd degree. And then if we're adding 1s here and 1 here, and that would make this a 2nd degree, this term. So looking at the largest degree in all of these terms, we can establish that this term, 3x squared y squared, makes this entire polynomial a degree 4. And to further specify this polynomial, I'm counting the number of terms, 1, 2, and 3. And so 3 terms means that we have a degree 4 trinomial. Writing polynomials in standard form. So the standard form of a polynomial is written in decreasing order of the exponents. And the leading coefficient is, after rewriting in standard form, it is the first coefficient in the first term, just the numerical value and not the variable. So as an example, write each polynomial in standard form, then give the leading coefficient. So for my definition, it says written in decreasing order of exponents. I'm going to look at all my exponents, and if I have single variables, I'll write in an exponent. If you don't have a variable, empty numbers are just to the 0. But you won't have to worry about this too often. Right? So looking at the biggest variable with the biggest exponent here, I have 3, then 2, then 1, and then 0. So rewriting this as standard form, I'm going to begin with this term right here, negative 4x cubed, and then going on to my next decreasing in order, minus 2x squared, and after that, go into the next exponent, 20 plus 20x to the first, and leaving me with this last term, plus 1. So here is your standard form. And the leading coefficient will be the first coefficient of the first term. So in this case, negative 4. All right, I want to try this problem out and then come back after a few minutes. If you're back, we are looking at the biggest exponent out of these variables. So we have 4, 3, 2, 1, and then two single numbers which have no variables. So we'll leave them for last. So the standard form of this polynomial is going to be starting with 12b to the fourth and going to the next one, minus 3b plus 6b to the third. So this one, and then this one, minus 3b squared, and then b to the first, plus 2b, and then minus 7 and plus 7. Now it says to write out each of this in standard form. At the end, if you want to combine the 7s together, then you can see that negative 7 plus 7 will cancel out. So the standard form of this polynomial will just be this. 12b to the fourth plus 6b cubed minus 3b squared plus 2b. And my leading coefficient is going to be my first coefficient after rewriting this in standard form, which is 12. I simplify in polynomials. So as you saw in the previous example, we can simplify polynomials. In this last example, we were able to combine the 7s together, and they canceled out. So the same concept here. We have to be able to match variables of same degree. So variables that we can combine together, like these two, must have the same variable and the same power, or you can say same exponent. So the same variable and same exponent. So both of these must be true. Variables that have different exponents cannot be added together or cannot be combined. They're not like terms. Because this one is r to the 3 and this one's r to the second. Example number 3, combine like terms to simplify each polynomial. So what I like to do is underline the matching terms. I have y to the 3 here, and I have y to the 3 here. So I can combine those. I have y to the second here, and y to the second here. I only have one y to the second here. So combining the reds together gives me minus 2y to the cubed plus 2y to the cubed, and then minus 8y squared plus 1y squared. These two will cancel each other out, leaving 0y cubed. And then these two will be added in order to have a negative 8y squared plus a 1y squared. It's just negative 7y y squared. So in reality, my answer just becomes negative 7y squared. And because it's a single monomial and I don't have anything after that, I don't have to write this in standard form because it's already in standard form. But if I wanted to do my leading coefficient, then that would be negative 7. Go ahead and try this one out and pause the video when you're ready to go over the answer. As starting, I'm looking for the biggest exponents in this polynomial. Looks like I have x squared here and 3a squared here. I have 4 squared, but there's no variable a here. So these two are like terms. Now a times b and minus 5a times b are like terms. I can combine those two. They have matching variables and the exponents of 1s if you wanted to write those in. And after simplifying 4 squared, that would give you 16. And this 16 and 10 are like terms which you can combine. So starting out with the reds, I'm going to add a squared plus 3a squared. And then the greens plus ab minus 5ab. And then I did 4 squared, which is 16, plus 10 in the orange. Combining the set of these two first, I have 1a plus 3a becomes, combining these two, I have 1ab minus 5ab become negative 4ab. And then adding these two, 16 plus 10 becomes 26. So your solution is this right here. And it's already in standard form. The last thing you need to do is find the leading coefficient, which would be in this case.